Now we're up to cubics. So the degree gets higher. The first thing you should always check for is common factors. Because that might mean it's pretty easy. And let's look. Is there something that divides 5, 10, and 5? Yeah, 5. Is there something that divides x cubed, x squared, and x? If you see x repeated or the same variable repeated through every single term, the one with the lowest degree is always the common factor. So if we factor out a 5, 5 divided by 5 makes a 1. X cubed divided by x makes x squared. 10 divided by 5 is positive 2. X squared divided by x is x to the first. 5 divided by 5 is 1. X divided by x is 1. And now I have a linear factor times a quadratic factor. So can't factor linear factors anymore, but I might be able to factor the quadratic. So in looking at that one, I know that x squared plus 2x plus 1, leading coefficient is 1. So I need two things that multiply to x squared. Well, that's easy. X times x. And I need two numbers that multiply to make positive 1 that add up to 2. Well, there's only one way to make 1. 1 times 1. And they agree to be positive. So it factors to 5 times x plus 1 times x plus 1. Now, there's something called difference of squares that we just talked about when we were reviewing. But remember, there's also something called sum of cubes and difference of cubes. So it's not something that's kind of like intuitive, which means it's just like, got it. But what it's talking about is that when these terms are perfect cubes are anything to the third power. 1 cubed is 1, so 1 is a perfect cube. 2 cubed is 8, so 8 is a perfect cube. 3 cubed, 27. 4 cubed is 64. 5 cubed is 125. 6 cubed is 216. 7 cubed is 343. 8 cubed is 512. 9 cubed is 729. And 10 cubed is 1,000. So those are the first 10 perfect cubes. So let's go ahead and look at one. So first, are both terms perfect cubes? Yes, x cubed is x times x times x, and 64 is 4 times 4 times 4. So I know that there's a sum, so it follows this rule. So what I do is I do the cube root of x cubed, which is x, and I find the cube root of 64, which we already said is 4. So this is my A, and this is my B. And then I just follow that rule. It says that x plus 4, that's my first factor. And my second factor is the square of the first one, x squared. The product of the two, 4 times x. And the square of the second one, 4 squared. So let's try that with this one. So I know that 27 is 3 cubed. X cubed is obviously x cubed. And 8 is 2 cubed. So that means my first term, the cube root is 3 times x, so that's my A. My second term is 2 cubed, so 2 is my B. And since it's subtraction, it fits this one. So I would do first term minus second term's cube root. Then I square this. 3 times 3 is 9. X times x is x squared. Then I go ahead and multiply them together. 3x times 2 is 6x. And it gets a plus sign according to the rule. And then I go ahead and I square the second term, 4. So 3x minus 2 times sin x squared plus 6x plus 4, all multiplied out. So now here is a cubic polynomial that doesn't really follow any of those other rules. But 4 terms. Guess what? We can use that magical box again. So how it works is we don't need to use the x this time. Yay! 3x cubed positive x squared positive x minus 12x minus 4. 1 in each box. Now I just factor. So 3 and negative 12 have a 3 in common. Positive 3 because the 3x cubed is the first one. And x is the common factor. X squared and negative 4 have nothing in common except a 1. So I put a 1. And it's positive 1 because positive 1x squared. Now I'm going to go ahead and look at rows. 3 and 1 only have a 1 in common. X cubed and x squared have x squared in common. Negative 12, negative 4 means I'm factoring out a negative because they both are negative, but also because the negative 12 is negative. And then 4 goes into 12. So that means it's minus 4. So what do I have? 3x plus 1 is my first factor. X squared minus 4 is my second. Now, that second factor, we've got to go ahead and we've got to double check it. It's quadratic. So before I can say this is completely factored, I have to check to see if I can factor that quadratic anymore. And the thing is, we can. Because remember that difference of squares rule that we did way back ago? X squared minus 4 is a difference of squares. It's the square root minus the square root times the square root plus the square root. So I get 3x plus 1 times x minus 2 times x plus 2. And again, you can multiply this out to see if you get that what we started with, but it does. Thanks.